So this is the next problem about, again, the applications of capacitors, of the combinations of capacitor in series and parallel. So as you can see here, we have 5 capacitors: C1, C2, C3, C4 and C5. All these capacitors, they have same capacitance, that is 10 microfarad. Okay, 10 microfarad each. So these 5 capacitors are connected between 2 point A and C. So here I have to find out the equivalent capacitance between the point A and C. So let us solve this problem. Okay, now this circuit problem, I can redraw it in this way. This is your C1, this is point A, sorry, this is point A, this is point C, this is point B, this is point D. Okay, so this is your C1, this is your C4, this is C2, this is C5 and this is C4. Okay, now how do I'm able to redraw this circuit in this way? Okay, look, this C1 is connected between point A and B. So here C1 is connected between point A and point B, and then C2, where is C2? Here is C2. This is connected between point B and C, B and C. Okay, C5, C and D, C5 between C and D, C4 between A and D, C3 between B and D. So same thing, it's nothing but it's just the rearrangement of the figure. Okay, so this circuit diagram, which is actually given in the problem, it can be redrawn as shown in this figure. Now, because C1, C2, C3, C4, C5, they are all equals to 10 microfarad each. So therefore, right, that we shall do in the next upcoming chapter, which is from electricity, about Wheatstone Bridge. Okay, so what does this Wheatstone Bridge says? He says that if the product of the opposite arms like C1, C5, C2 and C4 are equal, suppose the product, like in this case, if I'm taking C1 and C5 and C2 and C4, how much it is equals to? C1 is 10 microfarad, C5 is 10, C2 is 10, C4 is 10. So 10 mean 100. This also is 100. So what do we found? We found that the product like C1, C5, C2, C4, which is the product of the opposite arms, are equal. So we say that the bridge here, this Wheatstone bridge, is balanced. So when the bridge is balanced, then what happened? This point, this bridge, I will remove. Okay, that means there will be no more point B, there will be no more point D, because they are at same potential. Okay, because the product of the opposite arms are equal, so the bridge is said to be balanced. That we will do it better in the next chapter. So that circuit now, it will be further reduced to this one. So looking at this circuit, we can see that C1 and C2, they are in series. Similarly, C2 and C5 are in series. So when C1 and C2 are in series, then let's say the equivalent capacitance of these two, let's say it is C dash. The equivalent capacitance of these two is C double dash. So now we will find out what is C dash and what is C double dash. So because they are in series, so 1 upon C dash, it will be equals to 1 upon C1 plus 1 upon C2, which means 1 upon 10 plus 1 upon 10. 1 upon C dash is equals to 1 upon, okay, the LCM is 10, taking common, numerator you'll have 1 plus 1. Okay, this is 2 upon 10, which is equals to 1 upon 5. So your C dash is equals to 5 microfarad. So this C dash, right, it becomes how much? 1 microfarad. So therefore I will drop this now. I will have just one capacitor, that is C dash, which is equals to 5 microfarad. Similarly, because C4 and C5 now they are in series, so when you find out C double dash, again you'll get the same thing, that is 5 microfarad, because they are in series. So now I will drop this, I will replace with C double dash, which is equals to 5 microfarad. Now these two capacitor, 5 microfarad with this 5 microfarad, now they are in parallel and they are placed between point A and C. So therefore the total capacitance, right, of these two, it will be the parallel combinations of these two. So therefore when they are connected in parallel, then we have the final capacitance C is equals to C dash plus C double dash, and your C dash is 5, C double dash also is 5, so this is equals to 10 microfarad. So this is the answer for this problem. Okay, I hope you are clear with this numerical problems. If you have any doubt, please do feel free to ask me.